So today we're learning about quadratic systems. Quadratic systems. We've already done, I'm just going to remind you over here, linear systems. In fact, we've done them till we're blue in the face. Linear systems is basically two lines, and we look for where the two lines cross. And if you remember, we either solved that by graphing, or we solved it by substitution, or we solved it by elimination. The systems that we're doing now are basically the same process. The only difference with quadratic systems is you might have a parabola and a line instead of two lines, and maybe we'd have two solutions instead of just one. Or it could be a parabola and a parabola, but some kind of quadratic equation within the system. And we're still going to solve it the same way, either by graphing, substitution, or elimination. So what I chose here for the notes is to actually do some practice Psat questions. These are questions that are from actual tests that deal with the same topic. So we know with a multiple choice, like I could really work backwards, couldn't I? And plug in those ordered pairs into each equation to see which one works. And on a standardized test, you might want to do that. But here, I'm going to choose to solve this by substitution. So first of all, I want you to know that this is a parabola, and this one is a line. And on the homework tonight, I will have you graph them. But here, that's not in vertex form. I'm just going to solve this by substitution. I'm going to plug in the y minus 4 in for x. So y equals y minus 4 squared plus 3 times y minus 4 minus 4. So y equals, if I FOIL this, y squared minus 8y plus 16 plus 3y minus 12 minus 4. So now I'm going to clean this up here. So maybe if I just clean up this side first, this is going to be minus 5y, and what do I have? 16 minus 12 is 4. Oh, done. So that's just going to be 0 here, y squared minus 6y. So if I factor out a y, my y answers are 0 and 6. Now remember, this is a parabola and a line. I didn't graph it specifically, but it's going to have two answers. And what this is telling me is the y coordinates of each of those answers. So one is like something comma 0, and the other one is something comma 6. How could I find out that something? Right, plug it in. So if I take, and I could plug it into either the parabola or the line, but it's easiest to plug it into the line. So if I plug in y equals 0, 0 minus 4, so x is negative 4. So negative 4, 0 is one of my solutions. And if I plug in y equals 6, 6 minus 4 is 2, so 2, 6 is the other solution. So here in this multiple choice, it would be 2, 6. And of course, you could always plug in those answers, plug in that ordered pair to each equation, and see that it works. Here is an example of like a Psat question where you've got to bubble in your answer. So again, I'm going to solve this by substitution. I'm going to take the x minus 1, but now I got to plug it in for y, right? So x minus 1 is equal to x squared minus 4x plus 3. So if I solve this by getting everything on one side, minus 5x plus 4, so here I get x minus 4, x minus 1. I get two answers for the x. But remember, those are just the x values of the ordered pairs that are the solutions. To find the y values, I plug it in. So y equals 4 minus 1, which is 3, or y equals 1 minus 1, which is 0. So 1, 0, or 4, 3. Now this one's, because it's an SAT question, it says what is one possible value of the product of x and y? So it actually wants you to bubble in the product because you can't bubble in an ordered pair. So for this one, and usually we do this in class as just a practice of the bubbling for the SAT, but that's how you would bubble it in. You always justify it to the right. And you could put in a 12 or a 0. Then I have one here. This is a harder one. So this has got a graph already. And then it says, what is the value of v if the vertex of the graph is 419, right? So let's see, and it starts at 0, 3. There's several ways to do this. I've done it different ways over the years. Like sometimes people like to think of like the line first, right? It's easier to write an equation of a line, and I have the y-intercept that b is negative 9. If I want to find the slope would be y minus y over x minus x, or here negative 8 over negative 2, or 4. So that equation of the line is 4x minus 9. sometimes people have like done that slope a bunch of times, like up 4 over 1. So if I start with here and I go up 4, that's 2 negative 1. So if I go up 1, 2, 3, 4, the y value would be 3. And then over 1, so like 3, 3 somehow. And then again up 4 over 1. Wait, yeah, up 4 would be 7, so like 4, 7. Although I don't know if I'm on that right point yet. No, because that's a 4. So then if I go up 4 over 1 again, I'm at 5, 11. So like it could be. But I'm going to go ahead and write the equation of the parabola. So I'll do it in a different color. Now this one is harder than anything that's on the homework or on the test. In class we usually talk about this as being like a tough PSAT question. So we haven't done this yet. We're going to do it next week, though, where we can write the equation of a parabola. We know it goes right 4 and up 19. We also know another point on that equation is 0, 3. So if we let the y value be 3 and the x be 0, so 3 is equal to, this is 16a plus 19. So the a is negative 1. So the equation of the parabola is negative 1x minus 4 squared plus 19. So this is another way to do it where I've got both of these equations, the line here, the parabola here. And again, I want to know where they cross. So I could do this by, again, substitution. Maybe substitute in the 4x minus 9. So 4x minus 9 equals the negative of, I'm going to FOIL that out. So 4x minus 9 is negative x squared plus 8x minus 16 plus 9. I'm going to move everything to this side. I like to keep things positive. So x squared, I'm doing this in my mind, minus 4x. I'll just clean this up a little bit here. This is going to be 3. So when I move that over, subtract 3 from both sides, that's going to be negative 12, right? So x minus 6, x plus 2. So x equals 6, x equals negative 2. And again, I can plug in those values up for here for x. So 6 times 4 is 24. 24 minus 9 is 15. And then negative 2 times 4 is negative 8, minus 9 is negative 17. So I see two answers, 615 and negative 2, negative 17. And of course, the one that fits with the graph is the 615. And for the bubbling purposes, it just wanted the value of v, so it was actually 6 here. So I really didn't go far enough here. I would have had to gone up 4 over 1 again to 615. But maybe if I had had a better graph, I could have done it by just counting the slope of the line. So this is a harder one, and in class we do it as going over a harder PSAT question, but it does bring up a good point of writing quadratic equations. We're going to do that next week, so that's a harder one. But then to counterbalance that is kind of an easier one. It's a system of 3 equations. So this one is a circle, which we haven't learned yet, but you learned last year in geometry, and a parabola and a line. But the nice thing is that it's all done for us. And it says if the system, how many solutions does the system have? In other words, where do the line and the parabola and the circle all meet? Line, parabola, circle, line, parabola, circle, so that just meets in 2 spots. All right, so yeah, these are the notes on solving systems of quadratic equations.